Assalamu alaikum. Today we will learn about how to find the Laplace transform of a function which is multiplied with t to the power n. Suppose f of t is a function, and if this function is multiplied with t to the power n, then let's see how to find the Laplace transform of this function very easily. Suppose f of t is a normal any kind of function of variable t, and from the basic formula of the Laplace transform we have already know that the Laplace transform of this f of t is a function of f of s, where s is the variable, because this s is used in the main formula of Laplace transform. So this is known to us, and we can find easily the Laplace transform of f of t using the main formula. But if our required function is f of t which is multiplied with this t to the power n, then this is a complex form of any function, and if we try to find the Laplace transform of this function according to this main formula, then we will have to do many complex terms, and this will be more difficult. But there is a formula, direct formula of finding the answer of Laplace transform of this kind of function. So if our function, any kind of function, is multiplied with t to the power n, this n is a natural number, any natural number. So if they are multiplied with each other, then we can use this formula directly. Here the formula is minus 1 to the power n. Here n is the similar as t to the power n, and into successive derivative of this f of s for n times. And here how many times we will do this successive derivation? We will do this n times of the answer of function like f of t's successive derivation. Means if we find the answer of our first function's result, then if we will do successive derivative of this function, and then we will get our answer of this function. But at first we have to find out the Laplace transform of this f of t function, and then we will use the result here to find the answer of this whole function. This is easy or known to us, because this when we want to find the answer, we will use the main formula and easily we will get the answer. Then we will do the successive derivative of this function. How many times? This n times we will do successive derivation, and then this is multiplied with minus 1 to the power n. So let's see an example to understand it more clearly. Here is our question. Here we have to find the Laplace transform of t into cos 3t. Here this cos 3t is our f of t function, and this t acts as t to the power 1, means here n equals to 1. So at first what we will do, we will find out the Laplace transform of cos 3t. From our previous video we have already known the Laplace transform of cos at. So using this formula we will find out this. This is our basic formula, and now if we want to find the Laplace transform of cos 3t, then it will be s divided by s square plus 3 square, because here 3 is our constant term. So here we will write 3 instead of a, and the answer will be s divided by s square plus 9, and this is our f of s. So according to this formula, let's write the answer. So here we will write minus 1 to the power n. Here n equals to 1, so we will write here 1 into successive derivative of this f of s. Here f of s is this function, so we will directly write this function, and here we have to use the successive derivative of this n times, but here n equals to 1, so we will derivative this one time. Minus 1 to the power 1 means minus 1, and let's do the derivation of this. We know from the normal derivation s square plus 9 whole square. Then here we will put the lower portion as similar, and we will do the derivation of this upper portion. If we do the derivation of s, then we will get 1 minus, now we will took this upper portion as same as before, and we will derivative this lower part. Now if we derivative this lower part, we will get 2s plus the derivation of this constant term will be 0. This is the normal derivative. So now we will write the remaining terms. Here remains s square plus 9 minus 2s square divided by s square plus 9 whole square, and here remains minus s square minus 2s square means minus s square. So minus s square plus 9 divided by s square plus 9 whole square. And if we remove this minus, we will multiply this minus with our upper terms. So answer will be s square minus 9 divided by s square plus 9 whole square. This is the answer of this question. Let's see another example of this form. Here we have to find out the Laplace transform of t square into e to the power minus pi t. So here this is our f of t function and this is the t to the power n. So here our n equals to 2 because the power of t is 2. So here in the main formula we will use n equals to 2. So at first we will find the Laplace transform of e to the power minus pi t. From the basic formula we have already known that Laplace transform of e to the power minus at equals to 1 divided by s plus a. Here our constant term a equals to pi. So the Laplace transform of e to the power minus pi t will be 1 divided by s plus constant term. Here our constant term is pi, so s plus pi. Now let's, and this is our f of s function, and now we will use this main formula. So let's write the main formula. We have to write minus 1 to the power n, here n equals to 2, into derivative of this f of s function. What is the f of s function? 1 divided by s plus pi. And how many times we will do the derivative? We will do 2 times the successive derivation. Now let's derivate this term 2 times. Minus 1 to the power square means plus 1 into, at first let's our first derivation. So if we do our first derivation, then another derivative will remain and we will get s plus pi whole square. Here s plus pi will remain same, and if we do the derivative of 1, we will get 0 because this is a constant term, minus this one will remain same, and if we derivative this term we will get 1 for this s plus 0 because this is a constant term. So here if we write our remaining term, this will be s plus pi into 0, so the total term will be 0, and here only remains this minus 1. So minus 1 divided by s plus pi whole square. And now we will do our second derivative of this term. If we do the second derivative, we will get s plus pi square, and from the derivation formula we will get another square, and at the upper part this lower part will be same, s plus pi whole square, and into, if we derivate the minus 1, this will be 0 because minus 1 is a constant, minus this minus 1 will remain same, and we will derivative this lower part. What will be the derivative of this lower part? Here s plus pi whole square, so 2 into s plus pi, but this is not the s, the function of only s, this is s plus pi, so we will have to derivative this inner portion s plus pi. So if we derivative this inner portion s plus pi, we will get 1 plus 0, 1 for this s and 0 for this constant term pi. If we rewrite this term, we will get s plus pi, sorry, as this term is multiplied with 0, so the total term will be 0, and here remains only minus plus 1 into 2 into s plus pi into 1, and in the lower s plus pi square whole to the power 4. So answer will be 2 into s plus pi divided by s plus pi to the power 4. So our last answer will be 2 divided by s plus pi whole to the power cube. This is our main answer. So using this formula we can find our required answer easily, but if we do manually using the main formula, this will be more difficult. So যদি আমাদের ফাংশন এফ অফ টি কোনো টি টু দি পাওয়ার এন ফাংশনের সাথে গুণ আকারে থাকে, এবং এটাকে অবশ্যই এফ অফ টিটাকেও টি এর ফাংশন হইতে হবে, যার ফাংশন হবে এফ অফ টি সেই ভ্যারিয়েবলেরই টি টু দি পাওয়ার সামথিং একটা ন্যাচারাল নাম্বার থাকবে, এই দুটাকে অবশ্যই সেম হইতে হবে। তো যদি এরকম কোনো ফাংশন থাকে এবং এটার যদি ল্যাপ্লাস ট্রান্সফর্ম বের করতে হয়, তাহলে আমরা এই ইকুয়েশনটা ডিরেক্ট ফর্মুলাটা ইউজ করে ডিরেক্টলি ল্যাপ্লাস ট্রান্সফর্মটা বের করতে পারবো। বাট আমাদেরকে অবশ্যই প্রথমে ল্যাপ্লাস ট্রান্সফর্মের মেইন ফর্মুলা ইউজ করে এফ অফ টি এর অ্যান্সারটা বের করতে হবে, দেন এই অ্যান্সারটা এই ফর্মুলায় বসায় ডেরিভেটিভ করতে হবে, সাকসেসিভ ডেরিভেটিভ। কয়বার ডেরিভেটিভ করব? যতবার টি এর পাওয়ার যতবার থাকবে বা কোনো ভ্যারিয়েবলের পাওয়ার যত থাকবে ততবার করব, আর সেটার সাথে -1n গুণ দিব, সেটা কত এনটা হবে যত টি এর পাওয়ার বা ভ্যারিয়েবলের পাওয়ার যত থাকবে তত।